comes in. All right? Now, what is the lattice energy equation for this?
It's right. It's the.
No, it's not here. Tell me what is it?
Who?
Is that the Q1?
No.
That's Coulomb.
The lattice energy equation for the formation of sodium chloride.
Reactants.
No.
Is it NaCl?
What do you mean?
The formation. You want the formation of it. Just did it. Like,
It's broken minus.
no.
No.
So we're talking about the.
Delta H reaction.
Oh, right.
This is the lattice energy equation.
Yeah.
Okay? So Na plus gas
Yeah.
plus
Cl.
Cl minus
Gas.
gas
Produce
to produce NaCl
solid.
solid. The delta H of the lattice is negative 788 kJs. Alright? So now, this is the equation, this is our chemical equation. Okay? We know that all the little steps involved in making sodium chloride need to add up to negative 410.9 kJs.
Would that be the Hess law reference then?
Now we're going to do the Hess's law reference. Okay? Now, we're starting with sodium. We need to get sodium and chlorine looking like this. What do we need to do to sodium solid to get it to look like this? Huh?
So it's like a gas?
It's solid, so therefore we need to convert it to a gas. That's sublimation. Okay? So you have sodium solid going to sodium gas. This has its own entropy. Once you have sodium gas, what then you need to do to get it to look like this? You need to, what's it called? You need to ionize it. So we have sodium gas going to sodium plus gas and 1 electron. This has its own entropy. Now your sodium is ready. Now we need to work on chlorine. So we're starting out with chlorine gas. Cl2 gas. What do we need to do?
Have the entropy of that.
What do you mean?
Oh, it needs to change, right? No.
What needs to happen to it? It's already a gas, so you know that doesn't need to change. Well, we have-
Ionized? Not ionized. The other one.
No, we can't do that yet.
Half a level, please.
No. You need, how many chlorines do you need?
One.
So how much do you have?
2.
What do you need to do?
Get ready to.
You need to break this. This is a bond. This is a chlorine-chlorine bond. So you need to break it so we end up with 2 Cl gases. And this has its own entropy. Because you have 2, but you only need 1, what do you need to do? Divide by 2. Whatever this entropy is, you divide it by 2. So now you take your 1 chlorine gas that you need, and what do you need to do with it? Make it a solid.
Last electron.
You need to go electron affinity. So you have Cl minus gas. So now your chlorine is ready. And this has its own entropy. So now let's fill in the blanks.
You're gonna give us a chart for that.
I would give you all of these numbers except 1. And that is what I need you to find. I can either not give you the lattice energy and give you everything else and tell you to find the lattice energy, or I cannot give you the sublimation of one of them, and tell you to find the sublimation, right? So now, we need to remember how to set this up. Everything here is going to equal to this.
So when you add all of those up, you get that.
It should add it up. Okay, so here, sublimation for sodium solid to sodium gas is 108 kJs. Your ionization for sodium gas is 496 kJs. You need half a mole of your chlorine gas to break chlorine. To break the chlorine bond is 242. Half of that is 122.
It's 244, right?
No, 242.
It's 121.
It's significant figures. That's what it is.
So 122, you said?
122. Okay? Now gonna go electron affinity. You have negative 349 kJs. And your lattice energy for when you actually form it is negative 788 kJs.
And then you get negative 4 that
Which is the same thing. Okay?
Oh, you add up this negative.
You add up everybody. Tell me
I'm a little confused.
about.
So do they have CO2? Do they just have CO2 to CO?
Half CO2, you need half a mole of chlorine gas. To break the chlorine bond, it's how much?
It's enough. Maybe
242 kJs.
shut that to be.
So you have to find what is everything is.
Chlorine bond, 242, right? Now, how many chlorines do you need for sodium chloride? 1. So, how many, when you break your chlorine bond, how many chlorines do you get?
You have half of CO2.
If you have half of 2 chlorines, how many do you have? How many do you need? There you go. You understand? Okay. What part of it don't you understand?
So I have one.
No, you don't have 1. You have 2. If you just ignore the half for a second, okay? Ignore the half. How many chlorines do you have here? 2. How many chlorines would you need here? So what do you need to do? If you break the chlorine bond, how many chlorines do you still have? 2. How would you get the entropy for one of them? If the entropy of 2 chlorines is 242, how would you get the entropy for 1 chlorine? Okay? Now, we're going to do another example, but let me finish this chapter first, and then we'll do an example. Okay?
That's not.
Yes. Good. Okay? Alright. So, covalent bonding. Covalent bonding, that's when you're sharing your electrons. Okay? Again, you have to take into consideration the attractiveness between your electrons and your nuclei, the repulsion between your electrons and the repulsion between your nuclei. This is going to give you how close or how far your atoms are going to be away from each other. Okay? Now we have polar covalent bonds. Polar covalent bonds is simply your unequal sharing of your electron density. This has to do with your fungal. Okay? Your fluorine is your most electronegative. You see how the electron density here for fluorine gas is basically even? But it is not so even with hydrofluoric acid. So, what happens here is that your electron density is going to be distributed which direction? Towards your fluorine. But for your fluorine bond, it's basically even, so your electron density is going to be basically even. This is what we're talking about with polarity. Your electron density being distributed unevenly or evenly. Alright? So, electronegativity, your trend. Your electronegativity trend is going to increase going to your right on your periodic table, as well as decreasing going down. You get that? Right. So we have something called your bond dipole. Right? Bond dipole is simply which direction your electron density is being pulled. Now here, this is how we represent our dipole. It is an arrow with a plus sign on the end. Your dipole, the plus sign, indicates where your electron density is being pulled. Your plus sign indicates where you have a partial positive charge. So if we were to write the dipole for hydrofluoric acid, what would it look like?
It's hydrogen, on the top of the hydrogen is plus.
No, it's right here. So you want to move this entire arrow.
Alright.
So where would it be? What would it look like? Be going this way. What about here?
It's equal.
It's equal, so you have this equal pulling.
So it's polar.
The head of the
It's
arrow.
non-polar.
The head of the arrow is the positive. And
The head of the arrow is the negative, where your electron density is located.
okay.
What does the partial part mean? That's something I don't understand.
Partial means where do you have the least amount of negative charge?
So in this case, the H.
That's the partial positive for here.
Okay, and then the partial negative is still out.
Yes, the partial negative, which would mean that there you have the majority of your negative charge. Okay? Now we do have an equation for calculating your dipole moment. All this is a plug-in. Alright? So here your R is your radius, your Q is your charge on your electron. Alright? We won't be going into that too much, but just be aware of the equation.
For the final.
Just be aware of the equation, period. Because you're going to need it in tool 2 as well. Okay?
What's Q?
Q is the charge. Big Q would always be the charge.
And it's gonna be in joules. Or not?
Charging.
No.
Is that nanometers? Is that what that
What nanometers? No.
meters?
That's dipole moment. Like that's the beers.
What would that? Oh, never mind.
Okay?
But dBis or dBags, and what kind of units are those? I know that is that unit, but like,
That is the unit.
what would that be broken down? Like, you know,
No.
no,
Like, there's nothing inside.
no. Oh, so they don't have any units, the other two.
What other two? They do, but those would be given to you. Like I can't remember off the top of my head what's the unit
Gotcha.
for
Okay, that's fine.
for the charge right now.
It's columns.
Huh?
Columns, coulomb.
Coulombs. Yeah.
Cool, okay.
Okay? So here, you're looking at the polarity based on the electronegativity of your atoms. Alright? The electronegativity difference between hydrogen and fluorine is vast. So therefore the polarity of your hydrogen fluoride will be much greater than the polarity between hydrogen iodine, because the polarity difference between hydrogen and iodine is very similar. So as your electronegativity increases, your polarity will also increase. Do we get that? I think that's it, right? Okay, so let's see. Do you want want to take a break first, or do you want to go back and do the questions first? The examples first. The examples first? Okay. So, here we go. Let's take... We're going to go do this old school. Ooh, Lord, what did I just do?
Wash up the people them things.
I don't know what I'm doing now.
Let's click on it.
Don't judge me. Don't judge me.
You sound like my brother just now. Oh my God.
Don't judge me. Your mama must be super cool.
No,
Yes, she is.
she's not cool.
Yes, she is. You a hater, that's what that is.
She's only book smart. She's not cool.
I'm gonna tell her you said
I tell her
that.
that all the time. She be sitting in that room and be in a book all day. But she's smart, not so much. I have a bunch of, I found one. Like, seeing if I can find it's where's the Yahoo thing?
No.
Look up those.
Homework is due tomorrow, right?
I have no idea.
Yes.
Okay.
8? Yeah.
Okay. So here we have a question, right? Calculate the lattice energy of what's this?
Silver chloride.
What?
Silver chloride?
Silver chloride. Okay? So now, we want the lattice energy. So what we have to do, the first thing you have to do is draw out all your equations that you would need. Alright? So, what is the enthalpy, what is the formula for the lattice energy? What is the equation for the lattice energy?
H silver.
Plus Cl minus.
Silver plus gas
Chlorine minus gas.
plus
Chlorine
chlorine minus gas
produce silver chloride solid.
produce silver chloride solid. And we want the enthalpy for your lattice, right? So now,
So what we don't know is the entropy?
what we don't know is this entropy for your lattice energy, okay? So look at the information they give you. You know that you're going to need, the first thing that we need to do is write out the full equation for the formation of silver chloride. Alright? So, you know we have silver solid plus chlorine gas. Lord.
Would it be CO2 gas?
CO2 gas to produce AgCl. How many chlorines do we need?
2.
1. So this must be 1/2. So the entropy of formation is what? They give you that.
Negative 127.
Negative 127. So now,
Quick question.
yes.
Before you go further, did you put the coefficient as 1/2 because you have 1 Cl on the other side?
Yes. Balancing the equation.
What's the information?
Negative 127 kJs. So now, what do you need to do to silver to get it ready?
Silver solid to silver gas.
Silver solid to silver, not S. Gas.
Plus
This has an entropy of
284.
284 kJs.
Or more.
What do you need to do to silver gas?
Turn it into an iodine.
Ionize.
There you go. You need to ionize it. Silver gas to silver plus.
Wouldn't that make it a cation?
Isn't it a cation?
But there's no.
Let me make you get it right.
Na plus was a cation.
Na. Is this Na?
No, but like.
Where do you see Na?
No, I thought all cat ions had
A plus
positive
charge. Yes, so N is plus.
But A jumped in, that minus.
N is plus.
I apologize.
You
It is
should.
plus.
Ionization. How much is that?
731.
Positive 731 kJs.
Can you hold up, because I can't see to the right. I can't.
It's right here.
I can't, it's too much there, like, it's easy to look.
Negative 70, positive 781?
Yes. Now what do we need to do to chlorine?
So the bottom is, what would be given, the.
No.
731, boo, not 781.
731.
Why you saying?
Y'all didn't say on anyone. That's not
Eighty
what you.
one.
So you saying this would not be given, the last?
I would give you one. I would give you everything but one of these numbers. I would give to you, for example.
You talk about the bond.
Listen. I would give to you silver gas equals plus 284. You need to know that this came from silver solid to write out this equation. You don't even need to write out the equation if you understand what you're doing. I will also give you silver plus gas and give you its entropy. You need to know that this came from silver
So if
gas.
well, what if you don't write that and you still get the right answer? You're gonna mark it wrong.
You don't have to write out the equations,
Okay.
but
Just
you
get the
have to
numbers
know
right.
the numbers right.
Okay.
All right? So now chlorine gas. What do you need to do to chlorine gas?
Break it.
You got to break it to chlorine, to 2 chlorine gases. How many chlorines do you need?
1.
So what do?
Divided.
Divided by 2. So this is 242 divided by 2.
It's 244 on the board.
It's 244? My fault.
122.
122 kJs. What do you then need to do with your chlorine?
Become ion.
It become your minus, so Cl minus
Cl plus electron.
gas, yes, plus electron,
It's negative 349.
negative 349 kJs.
Now you are both already.
Now you have everything ready?
Yes.
Okay, so now what we have to do is set. Sorry, now we have to set up this equation. Remember, everything has an equal sign. It must equal to something. Do we get that? What does this equal to?
You gotta add up a little something.
No. What is?
This equals to the lattice energy.
Remember,
For the big one.
no. The entropy of formation. This is what everything equals to. Every little step, the lattice energy, the sublimation, the ionizations, the bond breaking, all of this equals to the entropy of formation,
Oh, these
Meaning
one.
the formation of silver chloride.
silver chloride. So this all equals to negative 127 kJs. So now you need to put everything over here.
To match.
So you have the delta H of your lattice, that's what you don't know,
Yeah.
plus 284 kJs, plus 731 kJs, plus 122 kJs, minus
Minus
349.
Can I ask you why, maybe it's two, what is it? Like for the chlorine, 280?
For the what?
For the chlorine and the silver, how do we know which one's adding an electron? Because you said that the electron part is the ionization.
What does chlorine need to do in order
To
to form
AgCl.
AgCl?
You were saying it has to donate an electron.
Chlorine does not donate an electron.
It adds an electron.
You add an electron to chlorine. What does silver do in order to make
It donates an electron.
it donates an electron? So you need to represent that. These are all the little steps that need to occur in just to make silver chloride.
So, we have to find the lattice energy.
Yes, that's the one that you don't know.
What is it saying?
You just find it
No,
by
it's not.
It's minus.
What do you mean minus?
It's gonna be negative,
It's 788.
but you.
It's 788?
Yes.
I don't know about that.
No, that's what you get when you add up all that
Negative
stuff.
915.
Don't you just?
What's negative 915?
Don't you add that to negative 127?
I don't know.
No,
That's what I'm
subtract that.
thinking.
I don't know.
You
All right,
add up
look at the math, look at the math. So pull out your calculators and type it in. You have 282, 284, sorry, plus 731,
It's 78.
plus 122, minus 349.
Minus 950.
What does that equal to?
788.
It's positive 788?
Correct.
Yeah.
Okay, so now how do we isolate, how do we get lattice energy by itself? Because you're gonna have delta H lattice plus 788 equals minus 127 kJs.
Add both of them.
You subtract
Subtract 788.
on both sides, so therefore what is my lattice energy equal to?
Negative 1915.
How much?
Negative 915
Negative 915
kilojoules per mole.
kJs.
How did you know that everything was equal to negative 1?
Because that is what,
That's what.
This is your
silver chloride
equation.
supposed to look like?
this is the equation for the formation of silver chloride. All of these little steps is what's needed in order to make this equation happen. So therefore, everything here must equal to this. So on the exam, I would give you delta HF for silver chloride would be this. So you need to know that this is the equal that goes on the
Right side.
right hand side of the equal sign.
Okay.
Okay?